Welcome to a new and important section of the course, Inbuilt Data Structures. Data structures are fundamental concepts in computer science. They are organized ways of storing and managing data so that it can be accessed and modified efficiently. In Python, several specialized data structures are readily available for specific use cases, and we will begin with the Queue module. 1. What are data structures? A data structure is not just a container for data, but a container organized with a specific set of rules. For example, the Python list is a simple, general-purpose structure. But when we need to ensure that data is processed in a strict order, like handling print jobs or customer service requests, we need specialized structures like queues or stacks. 2. Python's Queue module. For implementing classic data structures, Python provides the Queue module. Although it is named Queue, this module actually contains 3 different classes for handling ordered data, which we will explore in the coming lectures. Importantly, these classes are thread-safe, meaning they are designed to work reliably in concurrent environments where multiple parts of the program might access the structure at the same time. 3. Focus. The queue structure, FIFO. Our main focus will be the classic queue data structure, which operates on the principle of FIFO first in, first out. This means the first element added to the queue is always the first one to be removed. Think of a real-life queue at a checkout counter. The person who arrived first is the first person to be served. This strict ordering is critical for tasks like task scheduling and buffering. To summarize, data structures are essential for ordered data management. Our next lecture 38.02. Queue. See you there. Welcome back. In this lecture, we start working with the primary data structure in the Queue module, the LIFOQueue, implemented by the Queue class. We will cover the 2 fundamental operations for any queue, adding items to the back and removing items from the front. 1. Creating a queue object. First, we import the Queue module. Then, we instantiate the Queue class to create our task_queue object. By default, this queue is boundless. It can hold an unlimited number of items. We will see how to limit its size later. 2. Adding items, the put method. The method used to add an item to the queue is called put. In queue terminology, this is known as enqueuing. We add a number, a string, and a list to demonstrate that the queue can store any type of Python object. All items are added to the back of the line. 3. Removing items, the get method. To retrieve and remove an item from the queue, we use the get method, known as dequeuing. Because this is FIFOQueue, when we call get, it always removes the item that has been in the queue the longest, the one at the front. The output confirms this. The number 101, which was put first, is retrieved first, followed by the string analyzed data. To summarize, put and get are the core methods for FIFOQueues. Next, we will explore other essential methods for checking the size and status of the queue. Our next lecture 38.03. More queue methods. See you there. Welcome back. In the previous lecture, we learned how to add and remove items from a FIFOQueue using put and get. In this lecture, we will cover the essential methods for inspecting the queue state, checking its size, if it is empty, or if it is full, all crucial for building robust, reliable programs. 1. Checking queue size. The queue size method returns the current number of items held in the queue. This is a simple but vital method for monitoring the workload, especially in producer-consumer scenarios where one part of the program adds items and another removes them. 2. Checking status. The empty method returns true if the queue contains 0 items and false otherwise. This is often used to prevent calling get on an empty queue, which can cause the program to hang. The full method returns true if the queue is at its maximum capacity. Since our current queue is unbounded, full will always return false. 3. Creating a bounded queue. To make the queue have a limited capacity, you must pass the max size argument during instantiation. Here, we set the maximum size to 3. Once 3 items are added, the queue is considered full. If you attempt to call put on a full bounded queue, the function will block indefinitely until space is available. To summarize, these inspection methods are vital for controlling data flow and preventing unexpected program halts. Our next lecture 38.04, LIFOQueue. See you there. Welcome to our final lecture on the queue module. We have covered the FIFO-queue. Now we explore the LIFO-queue, which stands for last in, first out. This structure is more commonly known in computer science as a stack. The Python queue module provides the LIFOQueue class for implementing this behavior. 1. Understanding LIFO. The LIFO principle means the last element added to the structure is the first one to be removed. Think of a stack of plates. You always take the top plate, which was the last one put on the stack. Stacks are fundamental for tasks like managing function calls, which is often called the call stack, and for undo mechanisms. 2. Creating a LIFOQueue object. We create an instance of the LIFOQueue class. Note that LIFOQueues, like the standard FIFOQueue, also support the max size argument for creating a bounded structure, although here we keep it unbounded. 3. Testing LIFO behavior. We use the same put and get methods as the FIFOQueue, but the internal logic is different. We put items in the order 1, 2, 3. When we call get, the output confirms that action 3, delete, which was the last item put in, is the first item retrieved. This reversal of order is the definition of LIFO or stack behavior. To summarize, LIFOQueues are ideal for processes requiring reverse order access. This concludes our module on inbuilt data structures. Our next section is encapsulation using decorators, starting with lecture 39.01. Introduction. See you there.